Going. So first, hello to everyone. Thanks for joining, and we're certainly excited to give this introduction to asynchronous programming within the VAST platform. So, and of course, first, I'd like to say a special thank you to the UK Smalltalk user group folks for hosting this, for having us, and we hope you all certainly enjoy today's. So my name is Seth Berman. I'm the CEO of Instantiations, and joined with me today is Mariano Martinez Peck, who's one of our senior software engineers. So just a little bit about how we'll do this today. You know, my part essentially is going to be just to provide a quick sort of introduction to those who may not know about, asynchronous programming in general and the paradigm behind it. I'm also going to touch on some of the basic concepts and constructs that have been implemented in VAST to create this asynchronous library. And at that point, I'll be handing it over to Mariano, who has the majority of this demo or this presentation, which will be a live demo for you to see. And at the end, he'll touch base on kind of how this has been integrated into our product already, as well as some of the upcoming integrations not too long from now. Okay, so just a little bit of an introduction. Asynchronous programming, the paradigm, it kind of involves a new way of thinking about how programs are organized. Because of that, we're going to sort of start with a simple introduction explaining the basic concepts, the bottom lines of what's trying to be accomplished here, so that everyone can kind of follow the demo more easily when Mariano shares it. Okay, so asynchronous programming allows your computer to perform other operations while the asynchronous operation is running. So here's just sort of a brief example, a graphic example showing sort of your more traditional synchronous style that we're sort of all used to. We call a method, we get a return value from the method, call return. We're all pretty used to that. The idea behind asynchronous programming primarily involves splitting those two activities up. So we see here that there's an asynchronous call, and then at some point later, there will be a response returned. And in the meantime, this is kind of the bottom line crucial point, is that in the meantime, there can be other activities that are occurring. And we'll see, basically what we're after here, which is performance and efficiency. I mean, when it comes down to the actual asynchronous programming constructs themselves, what we're trying to do here is for, let's say, a given CPU, we're trying to maximize its ability to execute instructions. Also, this could be related to, spawning off different operating system processes or native threads of execution. And by doing those activities, we need some level of coordination. And so being able to have a paradigm that accommodates those activities and being able to organize them and their dependencies and what happens when exceptions occur. And that's sort of why we need asynchronous libraries. Because some folks, especially, us in Smalltalk, we've got, most canonical implementations have a Smalltalk process scheduler that basically can spawn off separate Smalltalk process tasks such that, as a block, you have a block of code, you can fork it. We've got basic constructs such as semaphores typically and other kinds of things to help control at kind of that fine-grained level. So what's the big deal here? What are we trying to show? Well, the problem with that is, as we scale these types of systems out, those are the asynchronous, the constructs, sort of the primitive and spawning an asynchronous task, but it doesn't really solve the issue of, how to coordinate various asynchronous tasks that have a lot of dependencies with one another, or what do you do when you have an exception in a given activity? How can you coordinate when things go wrong? How can you, now that you have a bunch of tasks that are, called at one point and returned at some other point, And, there's a lot now happening in ways a little bit different than the synchronous paradigm. We want to be able to make sense of those as we scale these programs out in the large. And so that's essentially what these libraries and what we'll be showing you today help us. So when might we want to consider using asynchronous programming? And so typically, say in Smalltalk, one of the big reasons would be for any sort of I/O blocking. So CPU is executing instructions, and then all of a sudden we have, a request to fetch data over a network, database calls, reading from files, and now we find ourselves waiting and blocking while we wait for the results of those kinds of calls. So naturally, we want to be able to have constructs that allow us to do that and then do other things while those operations are waiting. And so, and that's a primary use case in, say, single-threaded Smalltalk systems, but also there's what we see in VAST which is the coordination with separate operating system processes that are spawned. So we have a pretty powerful OS process framework that allows us to spawn and communicate with separate operating system processes and to get notifications when those processes complete. So our asynchronous libraries is completely integrated into that. Separately, we have the ability to make calls to C functions out on native operating system threads. Now, that does use some of the asynchronous constructs we'll be talking about, but it's not the same general purpose library that we have a while ago. There was very specific types of asynchronous higher level sort of frameworks developed to do that, but it's still using sort of high level asynchronous workflows. Okay, so now I'm just going to go over a few concepts because these are going to be the concepts that Mariano is going to go and show in great detail. The first two, we're going to talk about futures and promises. We'll get to, I think most people will probably be familiar with those. We'll talk about that you might not have heard of. And so let's talk about, what makes up our asynchronous framework. So the first is, many people might have heard of this, is a future. It's an object representing the result of a delayed asynchronous computation. So it's not the computation itself, it's the completion of such a computation. And it produces the result at some later point by either, returning a value or by raising an exception or getting an error. Or I'm sorry, that's the synchronous. You basically return a value right away or you raise an exception. So in contrast, with an asynchronous computation, we don't provide that result immediately, typically. That's at some later point. And because we might need to be waiting on something like, reading a file, querying from a database, and this all takes time. So instead of, blocking all computations until some result is available, the asynchronous computation immediately answers a future object, one of these, which will eventually, at some point in the future, be completed with a result. And the next construct we'll talk about is a promise. And sometimes the jargon gets in the way because there's languages like JavaScript that use the term promise, which really is more like a future. But this is more of the kind of the computer science definitional version of a promise, which is a way to produce future objects and to complete them later with a value or error. So most of the time, and sometimes people talk about it, it's two sides of the same coin. So essentially, most of the time, the simplest way to create a future is just to use one of our ESFuture creational APIs to capture the result of a single asynchronous computation. For example, you can just pass it a block closure and know that it will compute that asynchronously, and you'll have all the benefits of the futures API. However, sometimes you need to create a future from scratch. And for example, when you're converting something like a callback-based API into a future-based one, in this case, implementers can use promises to help them accomplish that task. And promises may also be used inside frameworks to provide a division between what the implementer is doing and what the user get. So it's a way to separate those sort of abstractions where users with futures and the completions of computations, and it is the implementer's job to take promises, and they know nothing about the users that are using any of the futures. And if you're confused at all by any of this, don't worry about it, because Mariano is going to show you exactly, these things in action. And so he's going to show an example of OS process that, is implemented using promises internally, but has a futures-based API. And so we'll see how that works. Okay, now this one you might not have heard of. And you could probably do the majority, 99% of asynchronous programming in VAST and maybe never have to deal with one of these, but it is really important because it gives a sort of a fine-grained control of execution and callbacks of asynchronous tasks. And it's it's used heavily in the implementation, and code is always sort of executed in the context of a zone, which is sort of an environment that remains stable across asynchronous calls. And so essentially developers can create a new zone that overrides functionality of an existing zone. For example, you can create a custom zone that can replace or modify the behavior of how asynchronous activities are scheduled, or how uncaught errors are handled. Basically, what we're trying to do here is draw a logical bounding box around a set of related asynchronous activity and being able to help them coordinate with each other. So zones can be used for helping to share data. So it's like a context object. Essentially, it allows, as I said, sort of bounding a set of asynchronous activities so they can all coordinate with each other, they can share data, and they can have, you can change the way they're scheduled or whatever you need to do. But it's certainly more of an implementer's tool, very fine-grained control over these things. And the last construct, which Mariano will be showing in detail, is probably my favorite. This is the asynchronous stream. So it's like a stream of asynchronous events that can also be treated like asynchronous collections. So each event is either a data event, also called an element of the stream, or it's an error event, which is a notification that something has failed. And when a stream has emitted all its events, a single done event will notify the listener that the end has been reached. And, of course, as you may realize, you can set up listeners that receive those events. These streams come in several different flavors, which Mariano will be talking to you about, and they're pretty neat and useful. Okay, so that's now what I'm going to do is I'm going to hand things off to Mariano. He's going to show you this live and in great detail. And certainly it's a pleasure to speak to you today, and I hope you enjoy the rest of the presentation. So with that, I'll go ahead and stop my screen sharing so Mariano can take over.
Okay. Okay, so now you should be seeing my Bast environment on Windows. And so first, hello to everyone. I didn't have the time yet to say hello. Thanks for staying. And it will be a long presentation with several demos. So my recommendation is that if you have questions, as Giovanni said, feel free to unmute yourself, ask. If you prefer to type it in the chat, then someone can interrupt me and tell me what is the question. So whatever works better for you. So we will basically follow the same order that Seth presented. So that means that we will start first with some futures demos. Then we will see 2 examples with promises. Then 1 example with zones. And finally, a few examples with streams. Okay? So before starting with the first example, I wanted to give a quick overview of what has been released in the different VAST versions. So right now, this image I am using, it's VAST 2023, which will be released at end of year. But futures and promises, they were released back in VAST 2021 or VAST 10. And zones and streams were released in VAST 2022, or also known as VAST 11, which is the latest stable version. So with what I mean is that everything I will be showing, it's present already in the latest stable release of the product, which is 2022. So if you want to play with these frameworks, you can always download a trial from our website. You can experiment or follow up the demos. And also, these examples are also on GitHub. I put all of these examples in a GitHub repository, so you can also grab the code from GitHub and play with that. So maybe one of the team of the Instantiations team will paste both the trial link and the GitHub repository if you want to continue. Okay, with that being said, I will start with the first example, which is with futures. In this case, if you remember what Seth said, a future is an object representing the result of a delay asynchronous computation. And he also said that the easiest way to create an asynchronous computation is by using one of the EFuture class-side creational API. The most common one is on. So you could say, for example, EFuture on a block, and that block will be run asynchronously as an async task. So you can think about this something similar. It's not exactly the same, but it's similar to what it would be if you fork this block. So it's similar. It's not exactly the same, but it's similar to a fork. So when you execute this, what would happen is that the scheduler will create a new separate Smalltalk process, just what happened with fork, that will be executing this code. Okay? So in this example, the code is really simple. It just prints starting the async task. It waits 5 seconds. Then it prints calculating 5 factorial, and finally calculates 5 factorial. Okay? And as we said, the result of this is a future that eventually, at some point, it may complete. So we do that, and then we continue printing, for example, async task fire, which happens after we have fire our asynchronous task. And then to the future, we could say then another asynchronous task. So this other asynchronous task will happen only once the previous future finish. In this case, once this asynchronous task has finished, then this one will be executed. And notice that the then API allows you to receive an argument which is the result of the previous future, the one that you are chaining with, which in the case is this one. So factorial, in this case, the argument will be 5 factorial because it's the return of the block. You know, in the block, the return is the last statement of the block. And then finally, we print finish scheduling. So let's see what happens when we execute this. Let's execute this. And we get async task fire and finish scheduling, we get these two first, because the code goes sequentially. Okay, at the beginning we schedule this task to be run asynchronously. Meanwhile, I keep going, and I print async task fire, and then I schedule another asynchronous task to be run after the first one, and then I keep running. So that's why you see finish scheduling next. After some time, the scheduler finished to execute this process, and it allows an interrupt point so that it can switch over and now execute our other Smalltalk process, the one in charge of this block. And that's why later you got starting the async task, because now the processor scheduler switched to the other process. We get that, and after 5 seconds we get calculating 5 factorial, and finally at the end, once this asynchronous tasks finish, then this one was executed, and then we print async task finish, which is the last one. So to conclude what is going on, it's we start our sequential execution and we schedule a synchronous task to be run. First one, and then we schedule a second one with the condition that should be run once the first one is completed. Okay? So this is the most basic concept of a future and what it is an asynchronous task. So if you have questions here, speak now, because all the rest will be basically built on top of this information. So if you have question, ask. Now we will see.
Yes, one question, Mariano.
Yeah.
So Silke from ETAS here, and we also tried some concepts with the ES Futures already, and we had the issue to transfer in future with an, for example, if you want to replace in your example the 5 by an integer, and you try to set up several futures like 1 to 5 repeat, and then do 5 futures in this repetition block, and then write out the integers factorial, for example. We had the issue that there was some weird behavior, I would say. Have you tried one of a similar example like I described?
So I don't know if it was the only me, but some of your questions went silent. I don't know, so like it was chopping.
Oh, sorry.
But I'm not sure I follow the exact example that you want me to run, but I can give it a try if you want to.
For example, if you try to say 3 times repeat and then put the block, that would be on top of the futures, to set up 3 futures,
so there's 3 futures
that do the same as your example block, for example.
Okay.
And then you have, instead of a 5, the integer as a parameter.
So you want to do something like this?
Something like this, yes.
And then what do you do with the future itself? Do you want to just run this?
Just to run this, and if you replace the 5, that is a hard-coded 5 now, by the repetition integer, first 1, then 2, then 3.
Oh, you mean like
like this.
I think that okay.
Yeah, okay, you haven't tried. I think that this will crash, maybe be too much for the first.
Yeah, maybe it would be maybe it would be too much. But if you want, we can because I don't know if it will hang, but if you want, I can try.
No,
Yeah.
what we saw that it always calculates 3 factorial. So the
I
last
think,
one it had.
yeah, that might be, maybe, I don't know, I should investigate, but that might be related to, let me see, times repeat. Yeah, I don't know.
That might be a
Yeah,
times repeat optimization.
yeah, that was
You
what I
have
was
some
thinking.
on that kind of thing. If you do 1 to 3 do, or
Yes.
1, 2, colon 3 parentheses and do, and then try that again and see if
Yeah, I was gonna suggest that
that
it
issue
might be
there's.
a optimization of the times repeat.
Yeah, okay, thank you.
So what we are suggesting for experiment is to do something like this. Instead of doing this, for example, may have an issue with the I argument because to do it's optimized, and the same could be for times repeat. So something like doing like this would be safer because you won't be running the optimized version. I think this might be what is happening for you.
Okay, thank
Okay,
you.
and if it's not the case, we can reach to you. We have your contact because I know you're a customer, so we can reach to you if does not solve it, and we can investigate it and get back to you with a more accurate response if that works for you.
Yeah, I think it's also a kind of personal interest of this behavior.
Okay.
And okay, thank
Okay.
you.
Sounds good. You are welcome. Okay, then let me save that. Okay. So now we will go to a more advanced scenario where we have two asynchronous tasks. The first one would just print calculating 3 factorial, and it would calculate 3 factorial, and then we have another asynchronous task that will do calculating 5 factorial and would calculate 5 factorial. So it's similar to the previous example, but we will have two asynchronous tasks running, okay? And we store the result into a variable, each of them into a different variable, and what we do later is we will use again the then construction. So we will take this future, the one returned by the 3 factorial, and we would say then wait for seconds 5 at random, so it would wait a random number of seconds between 1 and 5, and then it will print the result of 3 factorial plus 3. So basically it will take the argument, which is factorial, and print factorial plus 3. So this will be a second asynchronous event that will happen only once the first one happened. And then we do the same with the 5 factorial. We say the 5 factorial future, and we say then, and then we just print factorial plus 5 print string. So we just print this. So what we are doing is basically we have two async task schedule, and then another two where each depends on the previous one. Okay? And then what we do is we create a future. We say ESFuture all, and notice here we are using the curly brackets, which means an array. So we will be creating a ESFuture on all of these futures, which is this one and this one. Okay, so basically this future will be composed by this one and this one, and it will be completed only after all of its elements have been completed. So if I say here then, okay, this block, this asynchronous task will be executed only after this one finish, which basically means once these two have finished, and each of them will actually be executed once the previous one has executed. Okay, so it's kind of a workflow of asynchronous task. And if we execute this, what we get is calculating 3 factorial, calculating 5 factorial. These two guys appear almost immediately because these two asynchronous tasks were scheduled. And then some of them, for example, this one, wait less time because you see here the 5 factorial appear first than the 3. So that means that we have the two guys running in parallel, and this one actually wait less time than this one. So that's why we see first 5 factorial and the result, and then 3 factorial and the result, and finally at the very end we print I am done because of what I explained of what I previously explained. Now if we execute this again, we might see a different order between 5 and the 3 because there is an add random specifically here to see if we get luckily a different behavior. So in this case, for example, we got first the 3 and next the 5 because they wait different times. But this is to show you that indeed we have separate asynchronous tasks running in parallel, yet using the then and the all, etc., you can define your workflow. And that's the whole point of this, because if you would only want to fire, let's say you just want to fire a block and run it in the background, something like this example. Let's say you just want to run this and that's it. If you just want to do that, then using block fork might be enough. But when you start to have a real asynchronous framework or a workflow like this one, imagine doing this with fork. It becomes a nightmare because you will need to use semaphore to synchronize and get the workflow you want. And that's why all these pieces came useful at this point. Something I forgot to say, it's, I don't know if you notice that inside of the blocks I'm using a special method to print to the transcript. So here, for example, you can see I'm using the regular transcript CR show, but inside the asynchronous task I am using async show CR. And the reason is that because BAST expects that if you are gonna be modifying the UI, you need to make those modifications through the UI Smalltalk process. You cannot do it from another random process. You need to do it from the UI process. So what this method does, it's basically wrap self-show and CR inside a block that is passed to async exec in UI. This is a method provided by BAST even before all these asynchronous frameworks, and this method guarantees that this block will be executed within the UI Smalltalk process. So that's the only reason why I need to do that. Okay? And the next example, it's about exception handling. As you saw in the slides, one reason was efficiency of the CPU and performance, but the other reason of having these frameworks is because you want to be able to have somehow maintainable. And when you start having an asynchronous workflow, which is really hard to do with fork and semaphore, if you also bring the possibility that those blocks may throw exceptions, then things get even more complicated. So part of these asynchronous tools is to also provide some mechanisms for error handling. So in this example, what I have is a simple ESFuture on a block, like we saw before. And here inside the block, I will be signaling an exception. So imagine what is happening. You schedule an asynchronous task that will run asynchronously in a separate Smalltalk process, and then that process would throw an exception. So what we can do here is to use the catch API, and we also have ensure. So with the catch, you receive two optional arguments, which is exception and extract trace. Exception is the exception object that happened in the asynchronous task, this one. And the extract trace is an object that verifies the extract trace that happened with that exception. And of course, this will be an asynchronous task as well that will be executed only if there is an exception. So here what I can do is just print code error, and in this case I am just printing the description of the exception. We will see another example where we also use the stack trace, but for now I just print the description of the exception. And then we have ensure, and I'm just printing ensure. Simple. Now let's execute this, and you can see code error, an exception has occurred. Oh no, which is the all this is the exception description, and then we print ensure. So this is just to show you that we have a nice API to handle exceptions. Something I also forget to mention is that I strongly, if you want to use these frameworks, I strongly recommend you to take a look to the class comments and the methods comments. So for example, if you browse ESFuture and you go to the class comment, you can see how well and how detailed it is, all the class comments of ESFuture. And the same for the different API like catch if, ensure, then, and all the APIs that we have been seeing. You can see they are really well documented. So if you are exploring these frameworks, pay attention to that. Okay, now before going to promises, anyone has I see that there are some activity in the chat.
Your screen.
Sorry? You have a question? Okay. So
I just wanted,
yeah.
Sorry, Mariano, to interrupt. I just wanted to mention that there is no times repeat with an argument in VAST. So I just tested the one to a number by other number do, and it works just perfectly. I will paste the sample to the chat now, but while you were doing that, I was testing it and it just works. So
okay.
There's no
I guess I
times
missed
repeat with an argument.
I guess I missed that there was an argument. Yeah, no argument for times.
Okay.
So
Sorry.
it's not an optimization or anything.
I have a question.
Okay.
So if we're thinking about it at the hyperprobable retrospective sense of the BBC coin, how can stream to listen be retrospectively enhanced to connect?
You're asking about the streams?
Yeah,
So
I'm like a little bit lost on that.
We are not using streams yet.
yeah,
believe that
we didn't go yet to streams. So maybe after I show the streams, you might want to ask that. It's okay. Okay. I guess that was an okay. And if not, let me know. I think I understood something about the streams, but we will see streams later. So maybe I can reply. I can reply later. So any other question before I go to promises? Because all the rest is based on the concept of futures. So.
Okay, quick question.
Mm-hmm.
Is there real parallel processing or is this concurrent processing right now?
It's as concurrent as it goes with green threads, basically.
Okay.
So it's if you see, for example, if you remember this example, these two guys are two separate Smalltalk processes running, but of course, Bast is single native thread, basically.
Right.
At least for Smalltalk processes, Bast does uses separate native threads, but for specific things like, for example, for FFI, okay? But for normal Smalltalk processes, there will be only one executing at a given time. The whole idea here is to optimize the CPU usage so that you could have, if let's say you fire multiple asynchronous tasks, and whenever one gets stuck in IO or something, then you have another bunch of other process to continue executing. So that way you try to optimize your CPU usage as much as possible.
Okay, but all in one thread. Okay.
Yeah, one native thread.
Thank you.
Yes. You're welcome. Okay.
A little,
yeah.
Mariano, sorry, a little bit about that. If you have, let's say, 8 cores and you want to take the most out of it, you should have 8 vast images running?
Yes.
Okay, got it.
Yes.
Good.
I said there are some specific parts of Bast that use a separate native threads or CPUs, which is FFI calls that could be run async, but not in the normal process, Smalltalk process scheduling. And by the way, we have something very cool for what you asked, Sebastian, about having 8 images running. Says we can talk about this later, but we are implementing MQTT right now, which is super cool to distribute execution between multiple images. So that's something we want to explore. We are finishing MQTT at this point. A really nice implementation of the client B3 and B5. So that may be a technology that we could use for that. But yes, you would need 10 images if you want to use the 10 CPUs.
Good.
Esteban, you wanted to say something?
No, I wanted to mention that, I mean, the way that we've seen some customers leveraging multiple CPUs or hyper threads is to basically via the OS process frameworks we have, they coordinate or they orchestrate several processes from Smalltalk, and these processes are going to run very likely in a different core than the one that VAST is running. So let's say if you want to crunch some numbers, you can just trigger the number crunching in another process that might even be Smalltalk itself. But so basically you have a multi-VM situation or a multi-processes situation. That's the way that you can leverage multi-core architectures from a single VM.
Yeah. And by the way, there's a comment from what looks like is one of my employees, but it turns out that she got hacked. So my employee doesn't actually think this conference is boring.
Oh.
We were all very confused. We're like, Solveig, it can't be that bad.
Yeah,
But,
no, it's like
it turns out that her account got hacked. So I think that no.
Okay.
Okay. So now next, if nobody has any more questions, we go to promises. Promises, it's a much easier concept. Basically, a promise, again, in our nomenclature, in our names, a promise, it's a way to produce future objects and to complete them later with a value or an error. And the code it's as this. We can say ESPromise new, we create a promise, and then to the promise we can ask for a future, which is the future associated to that promise. Okay? Then to the future we can do whatever we want, just like we did in the previous examples. For example, in this case I am saying future, then another asynchronous task, which in this case it's just I am printing whatever I got, whatever the previous future responded, okay, which is a number in this case. So then I say, okay, transcript show about to complete the future. So let's execute this first. We execute this and we see about to complete the future. Okay, we just executed this. But notice that we didn't yet got the number printed because so far the promise has not been completed. But now I can tell the promise, okay, I want to complete the promise now so that the future will be completed. So if I said, now I say this, now I get 42 printed into the transcript. Because once I complete the promise, the future associated to the promise finish, and then it continues with the rest of the asynchronous workflow, which in this case it's a simple then, but you can imagine that this could be as complex as much as complex as, for example, this asynchronous workflow here. And to show a more advanced example, I wanted to show how we are using OS promises in OS process. As someone said, I think it was Esteban, we have a very nice framework in Bast for spawning OS processes. So what we could do here is, for example, we can say OS process starter start this command, which will basically just ping 6 times in Windows. This will take a couple of seconds. And then we say on completion, then, and I print process completed, and I print the process. And the process is what I get as an argument. So how this works? Where is the magic? Obviously on completion it's answering a future, because I am saying then this task. So on completion it's answering a future, and let's see how that works internally in the framework. So you can see OS native process on completion, and what it does, it's really simple. First, it creates a promise. This new completion promise is just a promise that it creates. And then it says, okay, if the process, if the native OS process didn't finish yet, okay, then register for completion notification.
Going to be...
Okay, so what the framework would do here internally is to just store the promise internally. It will store the promise so that when the native OS process finishes, it will be notified. So it just stores the promise. And the key aspect here is that the future is returned, and that's what the all completion returns. Is the future associated to the promise? Is the future that I am using here? Okay, so then it's okay. The framework creates a promise, answers the user the future, but then how is the promise completed? And what happens is that the virtual machine, whenever the OS native process finishes, which would be this ping, once the ping finishes, the VM will send a specific message to a Smalltalk, and that Smalltalk message will send another message, and eventually this method will be called fulfill completion promises. And if we see this, again, this is very simple. It gets the promises that were stored here. So here we store the promises to register for completion. And here it grabs the promises that were stored for completion, and then it just do promises do, promise complete with self. And it's completing the promise with self. With self is the native process. So when this line, when this exact line is executed, then this block, this asynchronous task is executed. Okay? And what is important here is that you can notice that promises help to differentiate the user of the framework from the implementer. It helps you to decouple that, because OS process knows nothing about what I would doing on completion. This is domain specific logic. Okay, so it's a really nice way. You can think about it like an alternative to what is the callback based API, where you plug your own callback. Well, this is similar, but asynchronously and using promises and futures.
Mariano, question: do we have here some API helping with merging them together, like to join? You have, let's say, 4 promises, and you want to do something only after.
Yes, exactly. Good question. We have an API in future which is called wait for, and the wait for, it's kind of a barrier that waits until all of them are until the future is completed. So there is a barrier.
Okay.
It's called wait for.
And it's,
so
it's a collection of futures. It accepts.
Got my helmet on my head. Let's figure out what that zombie said. Lava all over the room. Got a half heart left and I'm doomed. Don't have any iron bars. My picture's broken to some shards. Scary noise, what should I do? Go left or right, I'll have to choose. Visions of last time.
Giovanni, I don't know if you're around, but this guy has already did this a few times. Can we
just block the admittance?
Or block
just
or
do not admit.
Yes, sir. Big dick, big dick.
Okay.
Yeah, he's spamming some nice.
Yeah, I don't know how he gets in all the time, but just don't admit it anymore. What you were asking, Sebastian, is yes, there is a creational API to ES future, so you can say ES future all and pass a collection of futures, and then you can have a then block or a catch block to that collection of futures. So basically, you can coordinate or have kind of a barrier for all these futures and only execute what's afterwards once all the futures resolve, basically.
So, for example, here,
when the last one resolves, that's a very common scenario. Yeah.
Yes.
For example, here, let's say I don't want to do a then, but if I say here wait for, and then I do 42 inspect,
it will block.
It will block. So this wait for will actually will be blocking until the future is completed. In this case, this future will be completed once all of these futures are completed. So yes.
You have both styles. You have the then, but you also have the block, the one that blocks.
Yes, exactly. Wait for is kind of a barrier that will block until the future is done. Okay.
It's the Smalltalk equivalent of the await operator in some languages. So basically, it's just sending wait for. It's like preceding a statement with await. Just makes synchronous what is returning a future, basically.
Yeah.
By the way, I noticed that I didn't execute this example, so let me execute it. So here we get this, and then after 5 seconds or so, we get process completed, and we get the print string of the OS native process, which is it just prints the PID and the command line arguments, the command line. So this is the print string of the process of the OS process instance. Okay. So let's say there's a questions. Otherwise, we go to we have one example about zones, and then the promises. So if there's no questions, then I can move on to asynchronous zones. Okay. Okay, this example needs to be run in a workspace. That's why I brought from my notes into this workspace. And if we remember what Seth said in the slides, a zone represents an environment that remains stable across asynchronous calls. We will see exactly what that means. It actually gives us a kind of a context object for a set of asynchronous tasks that we want to group together. For this example, I strongly recommend you that you just watch the code I highlight, because if you try to see the whole code all together, you will get lost. So just focus on what I show, and I think it will be easier to understand. So what we have here, it's a block, okay? And inside this block, we have a 1, 2, 5 do, and we fire 5. And you can see here there's a yes future on a block. So don't focus, don't look yet what the block does. All we care is that we have a 1, 2, 5 do, and inside the do we have a ES future on a block. So that means basically that we will be scheduling 5 asynchronous tasks to do something. Okay? And to that block, we are going to send the message async zone values. So this is the message, async zone values. And the first argument of async zone expects a async zone spec, which we create here. And values expect a dictionary of data. Let's see first the data, which is easier. The data, it's just data that could be shared across the different asynchronous tasks associated to this zone. Okay? In this case, I will just store a single key, which it says greetings, and the value will be a collection of grapheme objects. So this is a Unicode string, and once we set as ordered collection to the Unicode string, we get a collection of grapheme objects. So this is our new Unicode support framework, which was released in the latest stable BAST version, the BAST 2022 or BAST 11. So you can see here all of the graphemes. So that will be the data that we store in our zone. And then we can customize the zone spec. And we are gonna customize 3 different aspects of the zone. Basically, we will customize on schedule task, on run, and on handle and coach error. So let's go one by one. The first one, it allows you to hook on how do you schedule the asynchronous task that will happen inside that zone. So for example, in this case, you can ignore all of the arguments. These are all really low level arguments that only matter if you are in the implementer side. So for the moment, don't focus on those. What is important here is this line. What I want to customize from the scheduling of the asynchronous task. Well, in this case, since this block will do UI modifications, I need to force that block to be executed within async exec in UI. It's the same thing like the transcript that I had to do before, that I need to do transcript, async, CR show. It's the same issue. So with this, I will guarantee that function, which is the block, the function argument is the block of the async task, will be executed within the UI process. So that's our customization for the on schedule. Then on the on run, we just add login. We just log, okay, running an async task, and we log that into the transcript. And then this, forget about this. This is just to continue the execution. It's like calling super. So it kind of makes the workflow to continue. So no, never mind this line. And then the last hook, it's on handle and coach error. So that basically means that it gives you a way to handle exceptions in any of the tasks that happen in that zone that nobody handle. Of course, I can have handlers inside the block, but if there's an exception that nobody handle, then here you can handle that. And the important arguments here are, as usual, the error object or the exception and the stack trace object. And what we do here is basically we create an empty file, async error text file, and then we do a stream next put all, a stack trace as a string. So we are basically dumping the stack trace into a file. Then we close the stream and we exit the exception. So those are our 3 customizations to the zone and the data that we store. Now let's see what our tasks do. What are asynchronous tasks doing? Well, they do the following. First, they wait a little bit. It's just some waiting. That it's I multiply by 200 milliseconds. Then we grab the editor. So here we're doing workspace all instances first. And since I only have one workspace in this image, because this is not workspace, I have only one workspace open. First would be this particular workspace instance, and if I ask the text widget, this will ask this scintilla editor that you see here. And then we access the zone, we access the greetings data, and we do a remove first. So basically we are removing an element from the shared collection that is shared across all the different asynchronous tasks. Okay? And then I just print the grapheme that I got. I call it value. I just do a add text to the editor. This basically means to add the grapheme at the end of the editor. Okay? So if I execute this, what we will see is that each of the grapheme, it's being grabbed here and added at the end of this workspace. So let's execute this and see if this works. And you can see them appearing on the bottom, each of them at the end. So first, I forgot to say that this is my workspace trying to say hello, UK. I didn't have a better icon, sorry. Hello, UK, Smalltalk, the balloon, meetup. So that's what the Unicode string means. So how can we know if this is working? Well, we can see this hook work because we can see that we were able to modify the UI without issues, because adding these things here, it means UI modification. So this aspect worked correctly. Then the on run, it should have print running an async task in the transcript, and in fact we get that. So this is also working because we can see here all the transcript shows. And finally, if there was an exception, then we should have a async error text file in the working directory. So let me check if that aspect work. So we do have an async error of at 4:18, which is correct. It's just two minutes ago. And if we open this, we see an indexed out of range. Let's see what happened. We see a remove at indexed, remove first on an empty collection. So we are trying to remove first on an empty collection. So can someone guess what happened here if you look at the code?
Not enough elements in the collection, right?
Sorry?
There's not enough elements in the collection. There's 4 elements in the collection, and we did 1 to 5.
Perfect.
1 to 5, yeah.
Exactly. Well done, Tim. Yeah.
Because I was curious about when the features start. They start on creation when they receive the on. They immediately start, or
yes, they are. When they receive the on, they are immediately scheduled. But it doesn't mean that the Smalltalk process scheduler will switch to that process immediately.
Right. Okay, cool.
Okay.
But they are immediately scheduled, right? Okay, so that's the answer.
Yes, it's similar to what would be a fork, but it's not exactly the same. Okay. So that's exactly right, Tim. We did a 1 to 5 when there were actually 4 elements in the collection. So the fifth throw the exception, which was not handled, and that's why we got our handler. Okay, so if there are no more questions, we will go to Seth's most favorite part, which is the streams.
There was one question in the chat,
Yep.
just
Okay.
noticed, which was, I think it was a good question, was you evaluate the block. Can you just bring the code back?
This one.
I think the question was, why do we do the evaluation of the block, I guess, on the on run? Is that just so that you can set the context of where you evaluate? I mean, would you always do that, or?
Sorry, I'm not sure I understood the question.
I think in the chat,
I did. Can I jump in?
Yes. Yeah, because I didn't understand.
So basically, the on run is just a hook that you can that the zone provides, so you can do something before or after the future is run within that zone. So it's not something special. It's just that basically a hook that you have to do something as soon as that future is run. So or the same thing with the on schedule task. It's not that you're running anything in particular. I mean, in this case, the example will have run the same.
If you took it away.
I can took it away. Exactly, I took it away. The only thing that would happen is that you won't see this in the transcript. So if we re-execute this, you will see, no, I don't have any workspace. I need to.
Yeah, you have to copy that to a workspace.
If we execute this without the run, you will see everything works as always, but you just don't have the hook, your customization on the on run. So all I wanted to show is that you have a lot of, and I didn't show all of them. There are even more customizations in the zone spec. So this is just if you want to customize several aspects of the scheduling, running, exception handling, etc. of the task that happen within that zone. But this is not mandatory.
Yeah, let's, as Seth said, it's 99% of the times you won't have to customize anything of this. Yeah. But let's say you have a custom error logging framework where you upload your logs to the cloud or something, then you might have for a specific zone or different futures that work together, you might do something with this specific zone and you can do something else with another zone. So it's I'd say it's just a context of execution for the futures. If you're just chaining tasks together and you don't care, you just use the default zone and don't specify any spec, and it will run.
Yeah, but this is cool, guys, because I was thinking you could have in the same image running an HTTP server that is going to do certain error handling, and let's say a raw TCP server that does a completely different error handling. And so you could have different policies and the server running the same image if that's something that an application would use, right?
Yeah, you could have a different handler for that.
Yeah.
Yes, that's correct.
And asking Joachim question about the parent run, yes, it's like a super call, because something that wasn't mentioned is that the zones can be nested. So you can have a hierarchy of zones, which is like a very complex scenario, but you can have basically like a hierarchy, and some handlers are going to be inherited by the child. So it's, if you want to have a very complex setup for all the zones, you can instantiate one.
Yeah, and something that we did, I think we've said it broadly, is that there is a default zone where all your futures, all your asynchronous tasks happen within a global default zone. That's why, for example, all of our previous examples, they did work without having to specify anything. That's why, but they do happen within a zone, which is kind of a global default one. This is just if you need to go an extra step in where you want to customize the different aspects of the zone. Okay?
Do you have something, Mariano, for the, let's say, because you mentioned at some point that they are kind of similar to forking, and I was thinking about priorities, and I see the on-schedule task. Maybe you can decide some kind of priority on a zone or futures.
Good question.
Yeah, I believe with futures you can assign a priority, I believe. If you look on the,
Yeah, I will need to check. I am not sure.
or it's relative. Possibly I'd have to look again, but I think it's, so if you like forked off a background task at a certain priority and then kicked off a future, then it would be relative to that priority of the calling process. But I think maybe there's an API for actual specifying the task priority level. But I can look at.
Okay.
Yeah, because I see very good hooks, and like it's natural to think, oh, maybe I would turbo this thing, you know.
Okay, so if everything is okay, we can go to streams unless anyone has another question. Okay, so now we are gonna switch to streams. Streams is so zones is a real, it's a very specific use case where might not be as useful. It's more like more of an edge case kind of thing. But streams are much more end user oriented, and there are a lot of frameworks that use streams. Something we didn't mention, and I think I could say it now, is that all these async frameworks, we port them from Dart, or we got inspired from Dart. So most of the concepts, most of the API, the test, we have a huge test suite that tests all the different aspects. They all come from Dart. And Dart uses streams a lot for different frameworks. And as you will see later in my last slide where we comment about the future integrations, you will see that there are quite some frameworks that they are already using streams and that they will use streams. So let's get started. So an async stream is an stream of asynchronous events that can also be treated like a synchronous collection. So what does it mean? So we will start with a basic example where you might not see the asynchronous aspect right ahead, but in the second example you would see it clearly. So here what we do is we create an ES stream from a collection. So we have the collection 1 to 5, and we say from collection, and that gives us a stream with 5 elements. Okay? And then we print a stream starting, and to the stream we can say listen. And this is the key aspect. The listen is the most basic API you can send to a stream and would allow you to define an asynchronous task that will be executed whenever the stream receives an event. Okay? So if we execute this, what we get is processing 1, processing 2, processing 3, 4, 5. Okay? So far it looks like it would be a normal collection, right? But let's see the second example, because in this case, this is the easy case where we are creating a stream from the beginning with a collection. But now we will see another example where the stream is being built asynchronously. So for that, we are going to use what is called a stream controller. And a controller allows sending data, errors, or the done event to each stream. The done event is a very particular event that the controller can send to the stream, which means that the stream should be closed. Okay? But 99% of the cases, the events would be data events, and sometimes you would also have error events. The controller can be used to create a simple stream that others can listen on and to push events to that stream. So that's basically what it does. So we can say, for example, eStream controller new, and we get a controller. To the controller, we ask the stream. Okay? Then to the stream, we can say, for example, do. I can say a stream do, like when you do it in collection, but this block will be running asynchronously whenever the controller adds an element to the stream. So let's execute this. And as you can see, nothing is printed. So notice that the do already I already said a stream do, but nothing is printed because nothing has been added yet to the stream. So later, asynchronously, at some point, I could say controller add 1, which 1 could be any object. It's an object. In this case, I'm using 1, I'm using numbers, but this could be any kind of object. So I say controller add 1. And when I do this, I will be adding an element, a data event to the stream. So when I do this, then I get processing event 1. So this asynchronous task run for the element that I just added. And the same go if I do add 5, I get processing event 5. I do add 10, I get processing event 10, and I do controller close, which close will send that special done event, which will tell the stream to close, and therefore the do will actually finish. So we can do that, and that will close the stream. So as you can see, here we are doing a collection API, but asynchronously. We are not doing that synchronously for the elements of the stream because we don't have yet the elements. The elements happen later, at a later point. So whenever the controller adds an element, then we get our asynchronous task executed. Okay? I can keep it for a couple of seconds if you want to process, because I know it's a lot to process. And what is important here is that yes.
No, I'm curious if you can use the customization of the zones into these strings too.
Yes.
Yes, because the streams will be using futures internally. So right. The on schedule, on run, etc. They will all end up affecting all of the asynchronous tasks that you run within the zone. So if you run streams inside a zone, then yes, I think that right. I didn't test it. I know if Esteban or Seth has an opinion, but I think
Yeah.
it should work.
Yeah, it would work because every future has to run within the context of a zone. And if there isn't one customly defined, it'll be the default zone. And so therefore any activity that everything's going to use futures at pretty much at the end, which then uses the scheduler. So streams, if it's inside a zone bounding box, will be subject to using the constraints of that zone. Yeah.
Yeah, because in the end, an asynchronous stream is just a producer of futures. So that's what it produces. It's kind of hard to think it that way for a Smalltalker, exactly. But what it produces, each element, it's just a future instead of the value.
Yeah, it follows all the rules.
What I was saying is that a stream, well, maybe I will say it later. Okay, so the next, I don't know if someone has any more question before it gets more complicated.
Presumably the implication of closing is if you do another add, we won't get a processing event, right?
Exactly. If you do exactly, you will actually get an exception. So if you try to do this, for example, you will get an exception saying that cannot add an event after closing because it has already closed the stream. That's correct. And also it has another implication, which we will see slightly later here in this point, where the API answer futures. You will see also why the close it's important. Okay.
I had another question. I don't know how much related it is to it, but before you showed a collection that printed sequentially, right?
Mm-hmm.
You had a simpler example for this. Yeah, this one.
Yeah.
And when you evaluate this, you have it's in sequence. Like
yes.
It's not that they are scheduled all at the same time and they can be ordered by the scheduler. It's like they are one up. The second one will start after the first one completed.
Yes. Yes. It? Yes. It's like that.
Right. Okay. Cool. Thanks.
No problem.
Which begs the question in that first example, what if you add something to the beginning of that collection before you listen? Does it then is it on the listen that it then starts processing these sequentially, or?
It's only you will only get, only those that get subscribed, because when you do a listen, basically what you get is a subscription, and you will get notified only for those elements that are added after you subscribed or the object subscribed. So if there were elements before, then they won't get what was added before they subscribed.
Although I guess a stream is add only anyway, so I don't think you can add to the beginning of a stream, can you? So probably
no. Yeah. The add is at the end.
Yes, yeah. And in this case, the stream, in the way that even if it provides a similar API to what Smalltalkers are used to, like a sequence, it's like a read stream or write stream. It's not exactly the same thing. It's just a synchronous variation. If you look, it's like the whole thing. It's the name. It is a stream, but it's not the exact stream that we are used to. So that's why it's different.
But in any case, Tim, there is an example about at the end about the broadcast.
Yeah. We're jumping ahead. We're excited.
Yeah, the broadcast might be related to what you are asking. Yeah.
Mariano, can you clarify when it starts? Because I'm not sure if it starts when you say when you instantiate the collection or when you say stream do. No, stream do doesn't make sense.
I think it's when you listen, it starts replaying what's in the stream in that very first example. I think.
Yeah. Yeah. In this case, it's on the do. On the do, it will start basically. Just search for the implementers of do.
Yeah, but it's not too easy. The implementation something I was going to show later, but I can show it now, is that the stream can have a much richer API like collection, so you can see select, collect.
I was going to ask that.
Yeah, that's
Yes.
and all of these methods, select, collect. In fact, here we have also here I have includes, and you will see that do all these guys are just facility. They are just helpers, where internally they are implemented using listen and something which is called the subscription that we are going to see at the end. So all those methods, do, select, they're all facilities developed by us that under the hook they use futures, the subscription object, and the listen kind of API. The listen is the kind of the basic one. And then all of these are just facilities built on top.
Nice.
So I should probably clarify one thing, because and I'm not sure if this was the question before, but I think there was a question about the order of which maybe the controller is adding data and then those that listen. So in this case, we have a listener via the do API attached first, and then the controller begins adding data, which then will fire off those events. But actually and Mariano will go over this, for single subscription streams, which is what these are, it will actually, even if you attach the handler later, you will get a replay of those events. There's a type of stream called a broadcast stream that we have, where that will not happen. When you show up, you are getting the events that are happening then. You're not getting the ones from long ago.
Yeah, okay.
Yeah.
Yes.
So it would be interesting to see what happens if maybe this is what Tim was asking, what if we do something like this, for example? Would it
try that.
And that should, let me clear this. You see that you do get the previous events in this case.
Right. Okay.
Yeah, because
in this case
it's a single listener one.
Exactly, because all these streams are what are called single subscription streams, in contrast to broadcast. And in the broadcast, you will see that this is not this does not happen. It's the opposite the opposite situation. Okay.
Yeah, and the single subscription is used most of the time for chaining, like when you're passing some elements across different streams, and you may do transformations in between. You can do whatever, and as soon as something gets added to the sync or to the input, then it gets along the way. That's the use case, or one of the biggest use cases it has.
Okay, before getting into the error handling, which is simple, any other question about this? Otherwise, we will see more. I mean, some of the questions are related to what we are going to see later. So
there's a script, aren't we? But yeah, no, keep going, I think.
Okay.
There was a question about, and it's a good one, and about listen was used. You used the API listen in the first example. I think maybe touch on it again, but you use do in the second example. Is there a difference as it goes between like those two? Like what is the relationship of listen versus some of these others? And I think you maybe were beginning to talk about that, or maybe there's another place you want to do that. But that was a question.
Maybe we can talk about that. I mean,
yeah,
both will print the same results. That's for example, this one will print 1 to 5, and if we do it's the same thing. Both will print 1 to 5. So from there, the result is what changed, right? Seth, one answered the subscription and the other one answers a future.
Yes, all the APIs essentially are built on top of listen in some way or another. Listen is sort of the most primitive version that allows that most fine-grained control. What do you listen? An event comes in. What do you do if there's an error? What do you do if there's a done event? And all these other APIs can sort of build themselves on top of that basic listen primitive, essentially. And Mariano's right. The returning result of a listen is a subscription, which is this other object he'll touch upon, which has a ton of its own functionality.
Mm-hmm.
Yeah.
Yep. And now coming back a little bit to the basic pieces of the framework, as we saw listen here. Obviously, listen is a method that simplifies some of the other aspects, but the most complex basic API it's listen, on error, on done, cancel on error. This is the most low-level API that allows you to customize the different aspects. So we have listen, which is exactly the same as the previous example that we saw. So in this case, when we listen for an event, I'm just printing the same thing, processing events, and we print the object. And then we can customize what to do on error. And again, as all our async frameworks, we can get an error object and a struct trace object. In this case, we print error event, and we print the error event. Then on done, and you can customize what to do once the stream is completed, once it's finished, once it's closed, basically. And then cancel on error and a boolean. This boolean, it just basically tells whether to cancel the subscription if there is an error. This is a small detail. So if we execute this, say, okay, we get this. So far nothing is printed, but again, if we do add one, we get processing event 1. And here there's the other API in controller to add error objects. And notice that the framework doesn't need to know what is an error. It's an object. It can be anything. This is domain specific, what an error is. In this case, I am just passing a string, but could be anything. So when I do this, now we get the error event. So this asynchronous task was executed because the controller added an error. Then if I do add 10, we get add 10, we get processing event 10. And of course, once we close it, and a team asks something about this, that when you execute the close, now you get the undone async task run. And we printed here a stream finish. So this method, listen on error, on done, cancel on error, this is the most basic method, and then all of the different API of a stream is built on top of this and other parts that we will see later. And in fact, I can show you, for example, if you look to eStream, we can see all of the API that we have built. So you can see all satisfy, any satisfy. You can see collect, detect if none, distinct, do, first, inject into, includes. So you can see how we have basically implemented most of the collection API into streams. And all of those methods are implemented using underneath this method and futures and the subscription object that we will see slightly later. Okay? Now, something I wanted to show is that I wanted to show that you can combine the different APIs. So for example here, let's take a look to this example. We have a ES stream controller new, we get the stream. To the controller, we ask the stream, and then I do a select for the I even. So, and there, in the same way that select returns a collection with a normal collection, in a stream, select returns a stream. Okay, the stream for whose even is true, and I store that into a variable. And then I can say, okay, to that stream, now I want to collect the event as float. And collect will also answer a stream, which I store here. So now if I listen, if I now listen to that stream, it should have both things combined. Okay? And my listen here is just to print it. Of course, as always, it could be anything. In this case, I'm just printing. And then what I do is just 1 to 10 do, controller add I. So basically here I am adding 1 to 10 into the stream, and then I close it. So can someone guess what will be the result of this snippet?
Keep it visible, please.
Sorry.
Thank you.
You have to guess, but you cannot look at the code. So it's
That's tricky. Yeah.
We are doing a select on Evan.
Right. You're filtering on Evan.
Even so 2, 4, 6, 8, 10.
Yeah.
And then collecting.
And then we are collecting that as float.
Yeah.
And at the end we print that.
Yeah.
So if we execute this,
It's the floats of all the evens.
Yeah.
Yeah, that's exactly right. That's it. We get 2.0, 4.0, 6.0, 8.0, and 10.0. So
yeah,
you can see.
What might be misleading here is that the stream, although it's the same variable there, is different streams. Every time you do a select or a collect in an ES stream, you get a different instance of an ES stream.
Right.
Yeah. Exactly. This answer a separate stream, this answer another stream. So I could have used different variables, but maybe that's even was more complicated to understand.
Yeah.
I don't know.
Or if you think it as chaining the different things, like wrapping them in parentheses.
Yeah, I could have done that as well.
That maybe would be very, I don't know, verbose, not verbose, but it will have a lot of syntax, but it will maybe clarify the flow of the data from the input to the result.
Mm-hmm.
So I'm right in thinking though that if you evaluated everything up to the close, we wouldn't see anything. And then if you did controller add 14 and then close, so like, sort of to kind of belabor the point, it's waiting for the close before it evaluates all of this, right? Have I understood? Like if you kind of swipe up there, evaluate, we're not going to see anything.
If I do this?
Yeah.
No, it
yeah, it will show it because I am adding here. I am adding at this point. I am adding.
You get the events. Okay, so it keeps outputting. Okay.
Yeah, it's like here. It's kind of what I did manually in these examples. I executed them manually. In this case, I'm just doing that from the code itself.
But
I guess because you're using collect, it can. I guess there's some operations you need the close before you can evaluate.
Yes, that's a good question. That's an excellent question. Let me answer to you in the next.
You didn't.
In the next point. That's an excellent question.
Yeah, but if you run up to where the cursor is, that won't show anything. But as soon as you
this will show anything.
And you add things, and then you will get the whole.
Oops.
Yeah,
that's because you don't have the variable.
Oh, yeah. Okay.
You lost it. No, you cannot do that.
Oh, okay. Well, now let's go to the next question, which will actually explain what Tim was asking. So there are some methods like, for example, let's go before getting into this one. Let's go back for a little bit to the do. Okay. We have a stream do, and what do you think the do will reply? When will it finish? Because I can keep adding elements to the stream as much as I want to. So what if we inspect, let's say, result here, and I do result inspect, what do I get here? Because I need to get an object, but the controller could be adding elements later.
It's an ES stream, I think, yeah?
Let's see. It's a future. The do answers a future because it cannot, as Tim said, it cannot answer immediately because I can keep adding things. Okay, and this continues to work. You see?
So the
but
close
now
must resolve that future.
Sorry?
The close must resolve.
Exactly. But when I do close now, the close will send the done event, and that means that the future can now be completed. So when now I do close, then this future is now completed. In fact, this is what I will show here. So if you understood the example with do, now we can see the example with include. So let's say we have a controller, we ask the stream, and then we say stream includes 5. And includes answer a future. So since it answers a future, I could say then this asynchronous task, which will print whether it was included or not. Okay, so let's execute this first. Okay, so far nothing is printed. Now I do add 1. Okay, nothing. The future didn't finish yet because you didn't see anything printed into the transcript. So the future is still alive. Now, what would happen now if I do add 5 with the include 5?
It will resolve that future.
Exactly, it will resolve the future, and that's why now I get included true, because it could know that the includes know that the future could be completed. And in the contrary, if I do 6, for example, okay, and we execute this, we do add 1, nothing happens. We do add 6, nothing happens. We do add 10, nothing happens. And I can keep going like that as much as we want. But if
Mariano?
I send close, yes.
Yeah, no, Joachim has a question that with the original example, with includes 5, but it returns a if you add 5 twice, what happens?
Okay, I will go.
Yeah,
I will go there in a second. So here, if I do, I will go back there in a minute. So if I do the close now, because right now notice that nothing was printed, because the future was not yet completed. But if I do close now, when I do close, now the future could complete because it knows that the stream has finished and 6 was not included. Therefore, it answers false. Okay, so that's, again, this is how includes it's implemented, how the do is implemented. These are API that returns a future.
But so
okay.
the stream, when you have it includes satisfied when you say
Sorry?
add 6, for example, when you have 6 if you put stream include 6, and
Mm-hmm.
you then add 6, you will get
Yeah.
the then block executed.
Yes. Yes.
One question is, if you have it added again, if you will have it again. That's
So
one
let's
question.
do that. What will happen is the following. If you do add 5 here, the subscription, the future associated will be completed, and you will be able to keep adding elements, just that it won't do anything. So for example, let me add 5 here. Let's say we do this, we execute that, and then, yeah, it's just once, because then the future will be completed. So I can do this. Now the future is completed. So now I can keep going. I can keep adding stuff, but I don't have anyone listening in this case. So the controller knows nothing. The controller just emits the event. Now, a different story if I close the stream and then I try to add an element. If I try to close, if I close it, and now I try to add, then I do get an exception. Okay? I guess that's
And the then block is executing under 2 circumstances: when the condition of the includes is satisfied, and on the close.
Yes.
Right.
Yes. Exactly. And for example, again, if it's, we can do, for example, here we could say future, and we store the result of do into a future, and then let's say we could say future, then 42 inspect, whatever. Okay, we execute this. Since this is a do, the only, and let's say we keep adding, we get that one, we get this one, whatever, we get this one. Now, the only situation where this future, where the do can finish, is when I close the stream. So when I close the stream, I get the 42 inspected, because the do was able to finish.
Is there a way to have an includes that remains active?
I don't think so.
A combination of includes with listen, so that it's always.
Yeah.
Sorry, what was the question? I couldn't hear it.
If there could be an include. Yeah.
I guess you're thinking in making a more complex query that's just including an element. Like maybe you have a condition that is.
It wouldn't be more like a
detect
like a filter. Yeah, I don't know. It's
Exactly, like a block that would give you an arbitrary Boolean that can carry something very complicated and get you.
Yeah, it depends on the future that it returns. I mean, you could use a select,
maybe,
and then it will be select every element in the input, and then it will just notify subscribers after each one of them answers true. So
if you have any satisfy.
We do have any satisfy.
There is
we
all
have
satisfy,
detect.
any satisfy, yeah.
We have detect as well.
So
okay.
Like have a listen block that has an includes call inside of the listen block. So you're always getting a new includes future with a then.
Yeah, I understand what you mean. I guess you can do that, but you will need to look at the includes. I did not test it, but I am assuming that you could watch at the includes implementation, probably hook into the listen. So you see here, it's calling listen internally, where it's passing nil. So maybe you can hook here with a includes listen do or something, and maybe pass that to here. I don't know.
Well, you mentioned any satisfy. That sounds like it might
Yeah, we have
do it includes that always stays alive.
You can open ES stream on the hierarchy browser. It's just show like the basic API.
Yeah.
That's going.
Yeah.
If you look at DS API category, you can see that there is
It looks like it's a subscription.
Nice.
We haven't learned about those yet.
So you have a lot of things to.
Yeah, you have a lot to if you want to expand.
Nice.
If you want to expand the current API, you have plenty of examples here to start with.
And that's basically what when I say that it is not exactly as the streams from traditional Smalltalk AD approach. It's a mix of a stream and a collection and asynchronous. So it's not, that's why the stream name might be misleading when you think just as something like a regular stream, but with something else. It's just a different animal, but you can use it following the same API as before.
Yeah, looking at the code for the any satisfy, it looks like it would actually the same thing. Once an element comes through that satisfies the future, it stops. So you just have to, I guess, engineer something to make that do what you want.
Yeah, I'm not super familiar with implementation.
Yeah, it just runs user code.
So
yeah, just open it. It just runs user code, and then if it evaluates to true.
Satisfy block, run user code, and I guess this one is different from the includes. That checks whether the object is equal to the other one, and the any satisfy evaluates the block with the element.
Either way, the future completes. So, or the future is satisfied. So yeah.
Yeah.
Okay.
Mm-hmm.
But this subscription thing sounds like it does not finalize on the first.
We will see the subscription right now, and there's not much to say, but again, this is mostly internal pieces of the framework, the subscription object. But what you can see in this example is that the subscription is the active object providing the events, and which can be used to stop listening again or to temporarily pause events from the subscription. So we can say ES controller new, we ask the stream to the controller, and then we do a stream listen, and we print it. So this is what we did in our very first basic example. So there is nothing new here. The only thing I wanted to show is that the listen answers this subscription object. And that subscription object can be used for various aspects. One of them could be to pause and resume your subscription to the stream. So for example, I can execute this, okay? And I can say add one, I get processing event one, but now I can pause my subscription, okay? I pause it. So now if I do add 5, I get nothing. If I do add 10, I get nothing. But now if I resume, I will get both of them because the events were kept while the subscription was on pause. Okay?
And this is because it's a single listener situation. That's
exactly
just to answer the same thing.
All these examples that we have seen, they are all single subscription streams. In fact, if you try to listen twice, and it's funny nobody asked for that, but if we try to listen twice, you will see that we get an exception saying a stream has already been listened to. So you can only listen once to the stream. But anyway, this subscription can allow you to pause, resume, etc. But it's also one of the fundamental pieces that is used internally for all the API that we saw: select, collect, do, includes, any, satisfy. Internally, they use the subscription object as well. But again, this is from the implementer side of the house. It's not for the end user. You just use the API, and that's it. And finally, the last example was about a broadcast subscription. And the way to create it is pretty much the same. We get a controller, we ask the stream, but here notice that to the stream you can say as broadcast a stream, and that makes the stream to be a broadcast stream. And the broadcast stream allows multiple subscribers, multiple listeners, not just one. So something we can do here is, let's say we execute this, and then we do a stream do. Here we register our first subscriber, which will do listener 1 processing event and print it. And then let's say we do add 1. Okay, listener 1 processing event 1. And now we register a second listener that will do a do also. So we execute this. Now it didn't throw an exception like I showed you a minute ago. Now it didn't show an exception. And in fact, but also notice that it didn't print listener 2 processing event 1, because those events already happened.
Right.
The event 1 already happened, and they are not kept anywhere. They are not hold onto. They are kind of fire and forget. So those events are not available anymore to the second subscriber. However, if now we do add 5, now we get both of them receiving the events. Okay? Now
each one
we get both.
Each one has its own future, right?
Exactly.
Some subscription. So
the same.
It's also.
Yeah,
but it's the same
actually.
Feature. I try to understand what happens with the green threads on those.
For the green threads, you can.
Or each one its own.
Each asynchronous task will have its own Smalltalk process, separate.
Yeah. Right.
So it will have its own green thread.
Yes.
And the React, when you add one, so you will have 2. But they did, the scheduler did respect the other. Well, it's the same data, so we don't know. Well, it's 1, 2, and 1, 2. It could have happened that the scheduler give you 1, 2, 2, 1.
Yes, it could have done that. Let me think.
All right.
I think it'll happen in the order of which it's registered. I mean, that's the current implementation of.
In the order they are registered.
Yeah, we're looking at a modified scheduler that'll do more of.
Okay.
Sets up a pool of Smalltalk processes for which you can, so you don't have to fire a separate Smalltalk process per async task. But when they actually get, you actually run this, top down, it'll get queued up in the order of which it was added. So that order is maintained.
Yeah, because when it's truly a thing, you're on the hands of the scheduler usually.
Yeah, well, the task itself, right, can do any number of things.
And something to add to this broadcast example that actually links to the example above is that you, in this case, the do was nothing, but you could, if you want, pause a subscription individually while keeping the broadcast stream publishing events. So basically, let's say you have 3 subscribers on a broadcast stream, and then you add elements that you can pause each subscriber independently. and then resume. And in this case, the resume won't get the queue of the past events. It will only resume getting events from that point forward.
You control that with what this answer, with what you get from the do.
Yeah, it's just like you
controls the
go
object.
Mariano to the post subscription example, the one above.
Mm-hmm.
You can do something like that, and you do listen, you get a subscription.
The listen.
Yeah, and then which is future. So
right.
Yep.
So in that example, if it was a broadcast stream, when you paused and resumed, you wouldn't see the previous ones. Is that right?
exactly. Yeah. Yeah.
Yes. Exactly.
Yeah. No, you won't because it's a broadcast stream, so it doesn't.
It's broadcast in a broadcast.
It's temporary. It will be discarded. If you missed it, you missed it.
Yeah, I mean, I don't know, Seth, but I think that if there was the need, you can somehow compose the different streams to have a preserving broadcast stream, but that, of course, that will be a lot of work. But I guess there's nothing stopping you from building something like that. But I don't know what would be the use. But
yeah, no, but usually you tend to need those things when you are in huge scale thing.
To keep the state?
Well, it depends on the application. Sometimes you can have eventual consistency and it's okay to discard because something in the application retries and it's fine. And sometimes you have to preserve, as you say, so you will have to do something.
Yeah, so I mean, a good example would be, and I talked about this in the chat, would be like MQTT. So we have the MQTT client coming in, which has a broadcast stream that you get as the user, which then gives you that stream of MQTT events. But MQTT is the one responsible for if you need resend or it handles those at the application level, whereas our stream single subscription versus broadcast, it doesn't really do that. That's more of whatever it's being attached to. So yeah, broadcast is literally like you hop on, you start listening, you don't get the history, and then you hop off or you pause it, and that's it.
Yeah, it's fine.
So that was all of the demos. Then the only last thing I wanted to show, and then we can have some more question if someone still has some more question. But the other thing I wanted to show is the upcoming integrations that we have in the product. So far, because I think it's important for us to kind of eat our own dog food, and also they are really useful frameworks. So that's why we start using them internally. So for example, OS process, as I have shown with the promises, we have in BAS 2022, we have a new streamed HTTP content retrieval, which basically means that now the HTTP client can gather data in a async fashion in chunks, and then start processing that data, contrary to having to retrieve all of the data and then process it all together. So that's using all of our asynchronous frameworks. In fact, I think it uses streams for that. Then we have a new event bus, which it will be part of the next release, but this is already done. It's a really nice implementation of event bus, which is a really simple, which it also uses streams. And then we have MQTT, which again it's almost done, and MQTT is also using the streams framework. And then upcoming, we have two other things that we would like to implement. They are on the roadmap, and they will be also using this asynchronous framework, which is the WebSockets, gRPC, and HTTP2. So those are on the pipeline. And finally, our customers' systems too. And as I got a first question from one of our customers, we have customers already using this internally in their systems. So that is really good news, because it's not only that we do it for our own frameworks, but the end user application can also benefit, which is really cool.
Guys,
that's it. Yeah.
Yeah, question about the MQTT. Are you guys using? How are you guys doing the? It's a bridge via FFI or an extension of the virtual machine. How are you doing that?
Yeah, I can answer that one. So
Or it's just sockets.
Well, we originally looked at wrapping the PAHO C API, and of course, in fact, that was one of the reasons we ended up doing threaded call-ins, was because the PAHO's library actually calls back into the VM on separate native threads, which originally caused some issues, as in crashing our VM. But then after that, became clear that so then we implemented async. That all is good. But then it became clear that, MQTT is not all that complicated. At the end of the day, the spec is pretty small. So what we wanted to do was implement both the version 3 series and version 5 together as one project. So we ended up and make this really simple without a lot of setup. So we ended up implementing that in pure Smalltalk. So the protocol.
It's a pure Smalltalk bridge. Awesome.
Pure Smalltalk. The packets are in layout and protocol are all in Smalltalk, and the client and the stream integration is that, and it implements the automatic heartbeat. You don't have to do the ping request and responses. It does that for you. It does automatic reconnects. It does pretty much everything. So all you do is topics, and you get a published stream, and you read from there. Off you go.
I think we had,
and that's one of the things with
Tim
WebSockets
last month that covered some of that as well.
Yeah. So working with it now, it's pretty neat. WebSockets, that was another, because we want to integrate that into the MQTT client so that folks don't have to open up, especially for our enterprise folks who tend to have more difficulty going to request that certain ports like 1883 for MQTT are opened up and other things. Instead, we can go directly over the standard HTTP ports. And of course, the SSL will be integrated into MQTT as well. So hopefully, I'm certainly MQTT WebSockets will likely be ready as well for 2023. So coming up.
Nice. I have something that could be using those WebSockets. Cool.
Okay, so that was it. That was the whole presentation. I wanted to thank everybody for staying this long. I hope you find it useful. But we are, if you have still more questions that they were not answered, feel free to ask, and we can go back to the demos if someone has an extra question. Okay. So
you're not going to escape that quick. I'm sure there's burning questions. I did want to ask, just in terms of VAST, how does it look on a Mac? Does the scintilla bit work in a Mac? I haven't used it in ages actually, and I'm curious.
No, the VAST platform works natively. It works on Linux and Windows. Right. It does not work on Mac. So we have users using it on Mac, but through virtualization, like myself.
Okay.
I have a Mac, but I use it through virtualization. We do have it in the roadmap, but it's not in the immediate roadmap, basically.
Yeah, that's fair. But it's in Linux already.
Sorry?
In Linux already.
Yes, in Linux it does work.
But there's no
but
scintilla in Linux.
there's no scintilla exactly. We are using the motif library for the UI. So
Yeah, that's only the UI.
yeah, that's why
I'm thinking in a backend. Sorry.
Yeah. So before getting into Mac, we will need to have first, in my opinion, we should have first something like GTK integrated, and then it would make sense to go to Mac. But I know, truth be told, is that every in a while we do some surveys with our customers to see which features they would like the most. And because, as any other company, we want to spend our money where
Of course, yeah.
we get most of the back. It doesn't seem to be a high demand for developing on Linux or developing in Mac. For example, we have a little amount of customers using Linux, but the ones that use Linux is for deployment.
Yeah.
So we don't have much customer asking for developing in Linux or in Mac. So
it's those powerful new Macs that are cool. I just wonder how long before enterprise sort of like kicks in and thinks, Christ, we got to use these. But
well, yeah, I mean, Mariano, you should tell your setup. You're on a Mac.
Yeah, I am on a Mac M1. I am running on Windows 11 ARM, and it's blazingly fast. I mean, it's
so
a really
you're
nice.
able to emulate it. Yeah, okay.
Yeah. In fact,
you can mention ARM support.
Yeah, we have ARM support for both 64-bit and 32-bit for Linux. So far, we have the ARM support for Linux, but in this release that it's upcoming, we will have support for Windows ARM. So that means that on Windows it will go even native with the ARM support. There won't be any emulation going on. There will be virtualization, so you will still have VMware or Parallels or whatever, but you won't need the Windows emulation layer to emulate Intel inside ARM.
Well, Bernhard is here. Let me chime in here.
Yep.
I think having a Smalltalk with native widgets UI on the Mac would be really cool. So I was hoping silently for very many years that this might be a possibility once. I know it's a lot of work because of the native widgets always are a lot of work, but this is something I would love to do, be able to write desktop applications which run on a Mac using native widgets.
Yeah,
me
too.
I have one very old application I fire up once in a while, and I need to run VMware just for that. And it doesn't look as nice, and yeah, it would be really great. So I'm not. Might be something I could imagine that quite a few Smalltalkers would want to use that. I would definitely.
Who's talking? Bernard?
But yes, Bernhard, that's me.
Okay. I have a pet project on that. You can ask me.
Yes. Actually, I was a very, very long time customer until last year, I guess. I paid the licenses, and I would be a customer again if that would happen.
Okay, sounds good. Yeah, as a Mac user, I would like to have it too.
I can imagine that enterprise customers are not that interested.
Yeah,
I can imagine that.
Well, yeah, I mean that's the reality of a commercial business, right? You got to go where your customers are asking you to be. Part first, so there's part one is figuring out where that is, especially in a domain like ours, which is platform, language, programming language and tooling. I mean, the amount of verticals of folks that we service is basically every vertical out there. So clearly everybody has lots of different, when you have that many verticals, everybody wants something different. So that's
I understand.
it's about what's important is number one. And then the second thing is just the reality of, okay, how many hundreds of thousands of dollars or more, depending on what the project is. I mean, certainly with the 64-bit VM that went on for 5 years, for which I was a member of, was an astronomical investment by Instantiations. And so that's got to be paid for. Otherwise, we would risk going out of business, which do our customers any good. So
that is true, because
so we run it. Yeah, we run it in a way that
bite your tongue, man.
Yes, I know. But see, this could be something where you attract completely new type of customers, which you don't have right now. So just saying. But I know
we do new customers.
Yeah, we do have new types of customers. Numerous. We don't. We actually do, and that's a lot of the explanation that you probably see us message about is as we move to more domains, we actually are getting different kinds.
Right.
We are, but we have to move slowly there because we can't just put everything into the area and then see if it worked out or not. We have to kind of know that, okay, we're gonna ramp up investment on this particular thread, put a bit more resources. We see that it's getting return. We're going to do even more. It's got to be at that pace so that we protect all of us, not just Instantiations, the company, but the collective hundreds of customers that we service. I mean,
right.
Since what, the 80s, like we run a stable business and we just run it that way.
Yeah, no.
Hey, listen, if you got some investment funds, where we can go. If somebody wants to do GTK investment, you just let us know. We'll go there and we'll whip it. No problem.
Yeah. Well, if there is a viable project, I would be the first to come to you. But right now, I'm just a single developer with my own personal projects, which I want to do. I'm even learning Swift to get this going, but it's not really. It's not nice.
Yeah, our Unicode support was based, at least the model. It's actually mostly in Rust, but the code model is somewhat like Swift's string model to a large degree.
Yeah. Actually, I started working on years ago. I started working on a bridge to SWT, so the cross-platform native framework which Eclipse uses, and I had it partially working, but then of course also this framework got abandoned, so it's not really a good target. So GTK would definitely be the better target, I guess.
Yeah.
But it's not. Is it really native on macOS? I don't know.
Say that again.
Is GTK framework really a native widgets, using native widgets, or is it emulated as well? I don't know. I have not looked into it.
So it's got some backends. I know that X11 is a backend for it, but I guess there's Esteban, more.
Well, GTK is native, but it's not like native as the same widgets that you have in Cocoa or something like that. It's just like native as something that's drawn on like locally, and it just has very high performance thing. But it's going to look, you can say, alien to what you have in a Mac.
Yeah. So
but it depends. I mean, like Flutter, for instance, it has all the widgets are emulated, but for the most part, you cannot tell because they are pixel perfect and they run at 60 frames per second. So it's if you can get something like that natively running on a Mac, then maybe you don't care that they are not native.
Yeah.
But we use a mix of native and emulated widgets on Windows. So it's
I know. Did you mention Flutter?
Yes.
Flutter and Dart.
Yes.
And it's a good framework to do things on.
We believe so.
So
So
will
for
that
for which
solve the
one,
web
Flutter?
problem going forward?
Sorry, the last question, I didn't hear it.
Will that solve the development problem going forward?
I don't know. I mean, we considered, well, we are, the whole asynchronous thing was based on Dart model, because we thought it was a very good model that we could retrofit somehow into Smalltalk way of doing things. We do some Flutter. I don't know if, I mean, we don't have plans of rewriting the whole UI and all the tools using Flutter, but although it has been mentioned, but again, it's something that maybe we are focusing more on this kind of solutions, like the synchronous thing, the MQTT, Unicode, a lot of things basically to not just being up to date, but actually providing something that actually moves the thing forward. So it depends. I mean, we don't discard any option for that.
So question, what is the product that you are making that Flutter and Smalltalk have been used?
No, it's not a product that we sell. It's we've done something internally for that. But it's not bound to Smalltalk in any way other than connecting to something that is Smalltalk based.
Okay, thank you.
Presumably all these futures framework pieces that you demonstrated, they would work on like IoT devices, right? Is that because I know you guys do a lot of work in IoT world, and there is all the tools to deploy to that kind of platform, and I guess these frameworks work in that arena as well. Is that right?
I think that makes sense, because in IoT, well, I have two things I would like to say. First, that makes sense to me because in IoT, there is usually a lot of I/O going on, like reading data from sensors, and there's a lot of I/O happening. So, and you have fewer resources, so you have less CPU available that you would have with a normal desktop server machine. So the more you can optimize your processor, I think the better. So I think it makes sense to me in general. And the other thing I would like to say is that MQTT, that Seth was talking previously, it was specifically designed for IoT. So even if you could use MQTT in various domains, the main reason why it was developed is it was for IoT. And no kidding, our implementation is using streams. So I would say that yes, it's a good set of frameworks for IoT, in my opinion. Yep.
And do you get all the tools? Because I remember like Vast has got like all kinds of remote debugging tools and all these sorts of things. You can connect to like remote VMs and do quite interesting things, can't you? It's that's still all part of the product, right?
Yeah, that's part of the product, and we have customers actually using that. In fact, I have seen some of our customers here. No, I don't know if they are still around, but I know some of our customers use these tools where they remote debug an image that they have deployed.
Yeah.
And they get a debugger, and they can you can even proceed deception. So if you can even resume deception, you can change code on the fly.
Right, yeah, and then redeploy it and it's really cool. Yeah.
Well, one of the many presentations.
Yeah, we did an example of that at the, remember Mariano, the IoT.
In the IoT, yes. We showed that in the IoT conference.
We did a remote control car where we had VAST deployed on a Raspberry Pi Zero, was it?
Yes.
Oh,
No, a
it is
Raspberry Pi 3.
A 3, okay. And it was
Yeah.
bolted onto a remote control car, which we did a little interface to. And then,
That's nice.
and then basically what we did that example where we had, you know, it live and we had a mistake in the code where instead of, what was it? Instead of turning
right to left or something like
so
that.
while it was in motion, we, you know, did the distributed Smalltalk, you know, made a change from another computer, pushed that code over to it, and then all of a sudden it just corrected itself as it was basically moving.
Oh, nice. Did that get recorded?
Those guys got a
I'd
kick
love
out
to
of it.
see that. That's awesome.
Yeah.
Was in
Yeah,
Riot, that thing?
Yeah.
Yes.
The Riot.
Yes.
And actually, yeah,
Yeah.
Mariano had in one of the many presentations done by Mariano, there's one that actually shows how to remotely debug, deploying to a Raspberry Pi and just firing the debugger back to his developer machine.
You have two ways. You could have that remote debugging, which is kind of a live debugging. You get the debugger and you can change code and resume. But then they also but for that you need a TCP connection between the remote machine and your development machine. But the other alternative that we have is kind of what I did for Faro, which is that you can serialize with Fuel the stack. So Bast also has that since forever. So you can, if you get an exception, you can serialize the whole stack trace with the data, with all the objects into a binary file. And then the customer can send you that binary file. And then you can materialize it and open a debugger with that materialized stack. Which of course it's not live. You cannot resume because it's a debugger. So it's like an alternative to the text-based wallback or
it's an order of magnitude better tool for doing post-mortem debugging, basically. Just having at least a context of where the error happened, not just a like text file or just a plain dump of the stack.
Yep.
And I guess just, you know, while I'm sort of understanding more about where Vast is up to, because I know you guys do a lot of different things, but in terms of Git integration, have you been implementing something to participate in that as well, so that there are ways of, because obviously you know, you got Envy, which is like really cool, but there's a lot of stuff that's happening in Git these days. Have you been working on that kind of support? Is that right? Have I remembered that correctly?
Yes, we have Esteban and me mostly having working in tunnel support.
Right. Okay.
So since I think it's 2 years at this point, we have been working in these large projects where it first started with just having tunnel support. So from Bast you can dump your code into a tunnel format that you can then import that into another Smalltalk using tunnel or vice versa. So we can grab any tunnel repository and then we can import that into Bast.
Yeah, but the thing is that, okay, go ahead, sorry.
No, the other thing is that what we don't have yet is the ability to, from within the image, we don't have yet the ability to commit, push, and do all the Git integration. So that's kind of done outside of the image with a command line. So what Bast does is convert from your applications and config maps into a tunnel repository, and then convert from the tunnel repository into Bast applications and etc. But we don't have yet integrated into the environment all the Git commands, basically.
The thing is that there's going to be always an overlap between MV and whatever tool we choose other than MV, and we are not dropping MV because it's like the core for source control management for our customers and ourselves. So Tonel is more of a format, but of course the use of Tonel requires that you have to somehow integrate it with Git. And then we have kind of like the Tonel tools in VAST, they just provide support for exporting and importing in Tonel format, but also has a few things like, I don't know, matching the base edition of an application to some that matches the parent commit ID in the Git repository. So we have kind of an integration, but it's not that you can, as Mariano said, commit and push right from VAST. But as an example,
but you can save a package into that format.
Yeah, actually, if you see, if you look at the Instantiations repository repositories in GitHub, or the VAST Community Hub repositories, all of them are using Tonel, and actually they were generated from VAST. And actually now while we have no, don't finish. But for instance, the latest seaside port that we did from the canonical repository back to VAST, we had to modify our Tonel tools just to support such a large project. But we could actually, with a few parameters, just load it right from the other repository and actually export it back to contribute upstream. And this week we have another big feature in the latest VAST release, which is the Unicode support. And we are, of course, as with the asynchronous programming things we are now rolling out those features into other frameworks. And of course, we don't have all the frameworks supporting Unicode strings. And for that, what we are doing is basically updating a few frameworks that we have, like NeoJSON, CSV, and Stone. And we were using Tonel tools to migrate from that, and it went just right through it. So we are kind of there, nice. But we don't have plans of dropping MV anytime. So
how do you map the users?
Sorry?
How do you map the users? So like email address of a Git committer to the NV user?
No, we don't map any users.
You get library supervisor as the code owner.
No, you get actually the Tonel tools are aware of the user. So basically, and the super user of STS, just in case you need to use that, just to work around something. So it will create all the editions and versions under the current user running the import, let's say.
Okay, I see.
And something I wanted to add about all the Tonel Git support is that most of our requests from our customers related to Git are not to replace MB, but because there is a mandate in the company that they need to have the code in GitHub. So they don't want to use Git as the version control system. They just want to kind of dump what they have into GitHub because there is a policy, because there is a mandate that comes through the company. So most of our users came with that requirement. We went further, but most of the time that's the requirement.
Yeah, but we had one customer that actually raised a lot of issues when they tried to import like a very large application, basically start from an empty image and just load everything from Git. It was a very large application with lots of applications in VAST terminology that you can think of as a package. And of course, some of the things weren't ready for that. So we did a few changes to the Tonel tools framework, and actually in the end they could just start from an empty image and then load everything from a Git repository. And it was a large application, not just a single small even UI things. So it's been tested as more users actually adopt it. But for like, I would say that for headless things, even for headful things like using the vast composition editor and stuff like that. But for a few things, there's always some edge case, but for the most part, it works. It's been an official feature since 2 years now, since VAST 10. So yeah, it's 2 years, almost 2 years now.
Yeah, but because think on CI/CD integration, you have to you have a pipeline when you merge the master and you want a new build. It's doable.
If you have a yeah, you can load.
It's doable. It's doable, and we have customers doing that even with MB. So, for example, Adrian, that is here, they do a lot. We have plenty of customers doing CI and building images, even with MB.
But with the Tonel.
No, that's. I mean, there's nothing stopping you from doing CI even without Git integration in VAST. But if you have Git integration and you can load your applications into an image, you can use the Tonel tools for that as well. So it depends on your situation.
It's just how you load the code into your image. If you have the code in Git repository, then you would load that with Tonel. If you have that in MB, you would just load it from MB. But the rest of the CI procedure is the same. We have plenty of customers doing CI with or without Tonel. That doesn't change.
Yeah, the thing is that for because I guess Seth doesn't know MV, but it solved dependency management a lot of time ago, and a lot of customers are really happy with the way it works. So
it's actually the config maps.
Right, but what I'm thinking is the other way around. It's think a new team that doesn't know MB, and they want to just use that because there is a pipeline which is part of another pipeline.
Yeah,
and
there's use case where actually you don't the way that VAST work is like all the code is held or managed by a library in a repository, basically it's like a central repository. So it's and the way that it works for most customers is that they all connect to the same repository. Of course, that some of them don't, but just like the way it was thought, it was to be used that way.
And for the dependencies.
Well, it keeps dependencies internally, and when you export something, it just exports the reference as well. But the thing is that you can use something in Git and just load everything into an image or a library that you consider disposable. So basically, you just load everything and use the Git repository as what it is. It's just a source, and then your MV library is just something that you don't care. But that's not the way that most customers, if not all, work. Just a few want to have and test. We are a few customers that load everything from Git using VAST. The good thing is that, of course, you get all the version tracking in a Git repository, not the Git repository per se, but the tooling around the Git repository. So that's it's easier to spot differences. It depends.
Cool.
Actually, I think that the config maps feature in Envy is something which is missing from the Git, from large Git projects. I worked many years with Git in large projects, and this is always a problem. And in Envy, you have config maps, and that's really great.
Yeah, but I think that the issue is like, I think it's fine that Git doesn't have config maps or anything like that, because they are two different things. I mean, Git is version control, and dependency management is another thing. In our case, MV solves both, but it has its pros and its cons. But in some cases, when you want to, for instance, use Git and MV, you have things version. I mean, you're keeping track of version twice, because you have a version in MV and a version in Git, and then it's just it's like two different paradigms somehow, because MV doesn't. If you're doing semantic versioning, you can commit as many times as you want, but you don't have to give a version name to any particular commit. And in MV and most version control systems that I am aware of, you have to do that. So it's like you version something, you tag a commit, and that's your version, basically, or you branch it. But in other version control systems like Envy, you have to give a version, even if it's something like garbage. You have to give it something. You cannot have just, unless you have open editions, of course, but that wouldn't work.
Yeah, it's interesting. I never thought of it that way, but it's a good point.
Yeah, I think that package is like the artifact, like the package, the dependency management between those packages, and the version control should be three separate things. I mean, should be replaceable in some cases, in the ideal world. But they are two separate domains.
That adds a lot of complexity, really. A lot of work going into that build.
Of course, yeah. Well, that's why many customers still prefer Envy, because for their Smalltalk product, it just does everything, and it does it in a very good way.
Right.
But it's not something. It's not the kind of application that a customer, let's say, our customers, they don't publish like features that other users can download from the internet, because if that were the case, then the dependency management and the package delivery should be something else. So it's,
yeah, I guess the main use case for the tunnel stuff would be cross dialect frameworks and porting.
Well, yeah, it does help a lot us, and of course to contribute back. But as I say, I mean, most of the improvements we've been adding to Tonel tools from the VAST side weren't driven by the needs of actually porting something, but actually our customers trying to use it. So actually we are focusing, actually we switched the default way of working, because there's kind of like a compatible format and a VAST only format. And we have the default now to be the VAST only format, because most of our customers use it that way. They don't use they don't want to go somewhere else. They just want to use Git for a particular application, or just to have some compliance in some cases. Other they want to start from scratch. Other have like distributed teams, and they need something like this. So it depends. So it's just another tool in the toolkit.
I guess round tripping is easier that way with VAST only format between Git and Envy.
Yes, well, it's the VAST only format. It's just in particular because one of the issues we have, which is like the biggest semantic difference between VAST and other dialects, is that shared pools in VAST are first class objects. They are not subclasses of shared pool, like in Squeak, for instance. So it's and the things we have, like all those pragma methods, they work differently in VAST. So just to avoid having to convert these into classes and then load them back, we just export that pragma method, and that's it. So it's just, yeah, it's a few things. It's not that much, but if you are in a VAST only, VAST to VAST situation, it works better.
I understand. Thanks for the detailed information.
I was curious, while we're just drifting across different topics, do you have any thoughts on sort of web front-end user interface ideas? Is that something, like we've had a few demos of other projects, like I guess a lot of projects, and I know Craig's on the call, they use oh god, what's the Squeak VM called?
Squeak.js?
Yes, not Squeak. Is it Squeak.js? Yeah, maybe it is Squeak.js. Just like, and obviously that's kind of a Squeak image format that it's able to run. Is there something equivalent, or is there something interesting from the VAST side for running things in browsers locally, or is it all kind of server side rendered up? And
yeah, I would say that most of our customers, they use SSD, which is like the server Smalltalk framework, just directly, or you see side for web? It's just like you have any client side things.
Yeah, in the research area, I mean, talking about research, not
Yeah,
something
of course. No, that's what's cool. Yeah.
yeah, something about that. I mean, an idea we could toy about at some point. It's our virtual machine. It's built using LLVM technology,
Right.
and that's why, for example, the ARM support is not too complicated because LLVM can generate the ARM instructions for us.
Yeah.
And LLVM has multiple backends. And one of
JavaScript, one of them.
WebAssembly, it's one of them.
Okay. All right. I see Craig's popped up now. There we go.
Okay, there you go. So WebAssembly is one of the possible backends of LLVM. So you could say that at some point we might try, I mean, as an experiment to be if Bast could be compiled to WebAssembly, but that's all I know. I don't know much more than that.
No, it's an interesting direction because it is cool when you sort of see that element of like, hang on a second, that's running locally, and some of this futures framework pieces that you've been showing us, running those locally on a machine starts to be you can take on board certain kinds of problems more easily, can't you? It's I mean it's a whole different paradigm, different ways of working, but it's certainly very interesting.
Exactly. Yep.
How far have you got on WebAssembly stuff, Craig?
No. Greg, sorry.
Yeah, Craig's over there. I know he's been.
You're mute, Craig.
Yeah, you're on mute.
I'm sorry, guys. I got another meeting. I got to take off. Sorry for interrupting.
Okay. No.
Take care, and it's really good to be with you.
Okay.
See you.
Bye,
Seth. Bye, Seth.
All right.
Thanks.